All right, everyone, welcome to MATHurdays. Math's so fun. We do it on Saturdays. My name is Teresa Wills, and in this 1 hour PD, you are going to get some experience doing a geometry problem that is accessible to even elementary grades. It's a great exploration that also has a lot of rich high school geometry topics involved. You're going to get a routine and a rich task along with all the blank templates and completed slides that you do in the PD today, and a recording of it will all be up on my website at teresawills.com/MATHurdays. So we're going to dive right in. If you're just joining us, welcome. We have some people who come frequently and can support us with kind of the norms in here. But if this is your first time, I definitely want to welcome you here. So you do need the interactive slides in order to participate today. I'm going to put the link to them in the chat box. Well, that's how you got here, but just make sure you have them open also. And on slide 2, some contact information if you want to get in touch with me. Slide 3 are where you can find some really great templates, and of course all the other recordings and information for MATHurdays. We have over 50 up here now, with a lot of different routines and rich tasks and more. And we're going to get started just getting to kind of know everyone on slides 4 or 5. We don't have that many people. Maybe we'll just do slide 4 today. So on this slide, you can insert a text box. You can insert an image. You can have emojis, bitmojis, GIFs, and more. It's unstructured on purpose, but let us know a little bit about yourself. It can be silly. It can be fun. For example, mine has a picture of my cat. Love my cat, but she finally got into her cat bed because it was upside down. And anyone who knows cats knows, yep, that's about right. That's how it works. So go ahead and add a text box here on slide 4. Again, if you're trying to get to those interactive slides, there they are. And Stacy, you say you have 1 week of summer school left. How's it going? Any tips for anyone else?
It's going okay. I've only got 3 students in there right now because it's summer and, it's an accelerated course. So it's, so you lose a few, but it was also the pandemic, the end of the pandemic. So there wasn't a lot left, but it's been kind of nice because they've been showing up to office hours, asking questions. So they're buckling down and getting ready for finals.
Very cool. So you're finishing up summer school. Laura, you're starting summer school. If there's one thing that you love that you did the first week, go ahead and kind of tell us what it is. If it is just flopping back and having a great nap, that works too.
Yes, I was going to say, so this is our first week. I'm doing summer school with third graders, and the majority of the third graders that I'm working, our summer school is in person. And the majority of the third graders that I have were virtual all year. So this is kind of like a stamina thing. Like how is it like being back in a building? How is it sitting in a chair? How is it being in a school building? So I have to say they were equally as exhausted as I was by Friday.
Absolutely. That endurance for kind of the 9 to 5, even though those might not be your hours, but that feeling of, that nonstop, even after a short break. I'm right there with you. We got some travelers. Who's going to Puerto Rico? Would you like to turn on your microphone? Tell us what's in Puerto Rico for you?
It's Tamika. I'm going, we're leaving on Tuesday and getting back on Sunday. So 14 years ago, my husband and I got married in Puerto Rico. And then it was a small destination wedding. And one of his best friends recently got married, not in Puerto Rico, but was in our wedding and wants to take his wife and his family because he had such a great time 14 years ago. So he asked us to come with them, excuse me. So we were like, should we? We haven't traveled anywhere since the pandemic, so we were pretty skeptical. But we finally went ahead and pulled the trigger, and so we head out on Tuesday to go back to our place that we got married. So we're super excited about that.
Oh, well, happy early anniversary and remembering of the wonderful times there. And I hope you have a wonderful time.
Thank you so much.
Yeah. Speaking of traveling, let's do one more. Who's going to San Diego?
I am. I'm going to go see my sister. I'm going by myself, no husband, no kids. And so I'm super excited about that.
Awesome.
For 10 days. 10 days. And so it's my little getaway before school starts.
Very cool. And just by yourself, like I kind of love being by myself sometimes too. So super cool. Well, folks, welcome. Glad you're here. I hope you take advantage of unstructured spaces like this with your students. It helps us to connect with other educators and it helps your students connect with each other and more. But we're going to jump into the math. I'm going to start off on slide 5. This is a routine that I've kind of just been doing over the years a lot in virtual instruction. I call it all of these, none of these. But if you have heard this from a different name or a different resource, this is interactive. Go ahead and put your resources here. But I'll kind of show you the structure of this routine. What you'll see are a bunch of slides below that are ready for you to type your name and claim one. That's how other people will know that that's your slide. Please don't touch it. I'm working on that one. Go ahead and grab a slide, type your name in the yellow box, and you're going to think of a rule. It can be anything. There's a lot of triangles on the left and the right. And if these triangles happen to follow your rule, you'll put them inside the oval. If they don't follow your rule, you'll put them outside the oval. And if you're just not sure yet, leave them off the screen, or if they just don't apply, leave them off the screen. And we're going to take just a few minutes to create an example of your rule, but don't tell anyone it. This is yours for now. Again, type your name in one of the yellow boxes to claim it for you. Other people will know that's yours. And move those triangles in to create your rule. Lisa asked a great question. Do you need to use every triangle? Nope, that's just a starting selection to get you thinking. Again, there's some triangles off to the left and the right of your slide, and those are for you to move them in. The next part of this routine is to up your level of thinking. Now, when I give you images, all you're doing is analyzing, does it fit, does it not? But I want you to increase the rigor here, and I want you to think of other images from the web that you can bring in here. So now you're doing a web search. One way of doing that is copying and pasting. Another is insert image, and then the little search the web choice. And you can find literally anything from a slice of pizza to a beach ball. Put it either inside the oval or outside the oval to really strengthen your rule. At any time, if you would like to get inspiration from your peers, go ahead and view some other slides. Once you get an idea, go search the web and add it to yours. try to think of some real world images, examples and non-examples. Love seeing all the pictures. It's helping me to solidify my thinking of your rule, and I'm about ready to guess some of them. All right, so thinking pedagogically, you started out sorting images that I found. Then you had a search for your own images, which increases that level of thinking. And now you're going to start guessing other people's rule. But you're not going to start typing in there, like, don't just type in the answer. Go search for an image on the web and add it to the slide below yours, either inside the oval or outside the oval, based on their rule that you think it is. Laura, you're the last one, so you'll just loop up to the top. So see if you can add an image to somebody else's. It looks like we have a new image on almost all the slides. So once you've guessed somebody else's, put that image in. You can go back to your own slide and make any corrections that need to be made, and now type your rule in the box. Make any corrections on your slide and type your rule so we know it. Yes, the blue box. Yep, the one that says keep it secret for now. Go ahead and tell us your rule. And Stacy, you're on slide 9. I'm really curious if you wouldn't mind sharing with us a little bit more about the at least point here. Why do you think it's good to sort and classify with the idea of at least?
It's one of the things that students ignore, that particular wording. And so they'll just see 2 and just only put all the ones that have 2 equal sides and just completely ignore any equilaterals. So just something I like to always hit them with.
Yeah, and you know, it's interesting, different countries, different states have different rules for things like trapezoids. Either they are a type of parallelogram or they're not, they're exclusive. Same thing with triangles. Sometimes equilateral are a part of this kind and sometimes they're exclusive. So it's really interesting to look at the rule and whether or not they use that word at least. Awesome. And then let's come down to which one was it? We had a lot of congruent at least. And then on slide 12, Roanna, you've got scalene right triangles. Are there any that you had to focus on, like that are scaling that are not right, or ones that are right and not scaling?
I just thought about it because just randomly when I was trying to sort the triangles, I thought why not look at only right angle triangles and which are not right angles. Then I observed that it could also be, then I got to know that there is a scalene and an isosceles triangle within the right angles. And that is why I went further into bifurcating only right angle triangles.
Lovely. And I like how you brought in the measuring by angles and measuring by sides in the same thing. And so we could get into some great discussions about that. So folks, what I'm hoping from this routine you gathered is a couple of really important things. One of them being simply classroom management. You were all engaged the entire time. There was always something to do, something else you can add, which definitely can support us in making sure all of our students are engaged. But on slide 16, I have the protocol of how we can make this task more rigorous each step of the way. The students are the ones who create the rule. They're the ones who show it with your pieces. That'll help them stay on the objective or big idea. Then they search. Then they guess it through a search. And each of these brings up that level of thinking a little higher. Alrighty, let's jump into our math task. On slide 17 is the rationale for why we do rich tasks. I mean, I like them, but I want a more research-based rationale. The National Council of Teachers of Mathematics have posted these 8 math teaching practices. You will see them all today. I have a very focused goal. This task is going to involve some productive struggle. It's going to be based on conceptual understanding. We are going to have so many different representations that's going to help us in our discourse at the end. But before we begin, I'm going to give everyone the opportunity to pledge the problem-solving oath that I have on slide 18. Just put your name in the blank when you read it to yourself. I, Teresa, promise to try my best. I will make sense of patterns and numbers. I will use manipulatives and drawings. I will make mistakes. I will ask questions. I will listen to other ideas. I will stay engaged by always trying to find another solution or representation. I am a problem solver. I make the world a better place. If you would like to pledge that today, find your chat box, make your name public, and make that pledge. And our task is on the slide below. So this place, Polygon Construction Company, is requesting plans for a mathematical museum building. They would like to showcase mathematical ideas using floor tiles. The building will be 20 stories tall, and they would like to use only square tiles. The first floor will be tiled with tiny 1 square inch tiles. The second floor will be tiled using slightly larger 2 square inch tiles. This pattern will continue all the way to the 20th floor, where they will use very large tiles that measure 20 square inches. The company would like you to arrange the tiles on grid or dot paper. Each page of your portfolio should show a sample of the square tile and a visual way to prove the area. There's 2 suggested virtual manipulatives. If you have others that you like for this, feel free to put them in the chat box and use them. Math Learning Center has a great geoboard, and Enrich Math has a great tilted square. And on the next slide, it shows what's allowed and what's not allowed. So you can have a square the way we normally see it with a base. You can also have a tilted square where it's kind of resting on a point. But the other 4 are not allowed. So without further ado, I'm going to pop you in breakout rooms. I suggest you do this more of a scavenger hunt and not in order, because some floors are going to be harder to do than others. So I'll pop you into breakout rooms and let's see. Let me just put these up. Alrighty, rooms are created. You have a place in Zoom that shows you where the room goes, but you might need to minimize your browser window to find it. Head on into your breakout room, and group 1 starts on slide 21, group 2 on slide 26, and group 3 on slide 31. So as you're joining your group, you might need to minimize your browser window to see the Zoom invite. It's kind of within Zoom and it likes to hide behind things. If you are watching the recording of this, what I do now is give them a solid minute or two without me in their rooms. That will help them with their community building, saying hello, learning a little bit about each other, and getting started. I'm also looking at the slides to see if anyone has any work up. If someone does not have any work up for a prolonged amount of time, I'll definitely reach into their room first.
It was safest to be on the computer, so I understand, but
Yeah. Good. Okay, so nice to see you. Let's see, somebody's typed our names in already. You're so fast.
I just did that. I was like, maybe
Yeah,
we know where
good.
to start.
Okay.
All right, so we're down on 31, right?
Yes.
Okay. So let me click on the GeoBoard app. I haven't played with a GeoBoard in forever. I haven't either. The one thing that I'm thinking about is the area of the floor. Yes. So as in like, the first floor is 1.
But I think I'm reading it differently than you, Stacy. Is that
Very
right?
same thing.
Hi
The
group, I was
sizes
just
are same.
checking in to see if I can support you understanding the problem at all, or if you just needed some more time to tinker.
Oh, I think we need help understanding the problem.
Awesome. So, perfect. We have one already up on your slide.
I just put that in there.
Yeah,
Group.
so what's the area of that square tile?
1 square inch.
Yep. So that's perfect for the first floor. And
How can you have a floor that's 1 square inch?
the tiles that they put down on the floor are tiny tiles.
So we're not tiling the floor. You just want to see a single tile.
Yeah, exactly. Mm-hmm.
Okay. Now I'm okay.
Yeah.
So on the second floor, what we would show would be a tile that has an area of 2 square inches,
Yep, indeed.
right? And we could do that in a couple different ways, right?
You can do it in many ways.
Right. Yeah.
I would definitely recommend that you do them out of order. Just if you think you know like the 4th floor, like pop that one in. And as more start to come to
Gotcha.
you, just start popping them in where they belong. And I
gotcha.
definitely encourage this kind of like, everyone try to find their own, but keep the mics on, keep the conversation going, because it gets pretty interesting as you make more generalizations.
Gotcha. And so they all the tiles have to be squares, correct? Is that what
Yes,
was
they
in
have
there?
to be
Okay.
squares. They cannot be
gotcha.
rectangles.
Okay.
bottom.
Okay. Uh-huh.
And then like 2 over, 3 over should be share screen.
Oh, okay. It's been so long since I've done it. Because school's out. Okay, so here's what I did. I just went over and I went ahead and took that picture that she had where it showed the square tile and said, okay, this one has an area of 4. And so that would be on the 4th floor. And we could do the same thing. I mean, and then I've also played with, let me see. I went to this tilted square thing. Come here, you. Get out of the way. And now I'm not sharing. Okay, so this thing, I started playing with this thing. And I said, okay, this is tilted squares one. And I would take what was I doing on this one? I can't remember. I like this. I played with the geo board, but I don't know if I was messing up because I was having to put I was trying to do a 3 square one. And I was having to put 4 different rubber bands to hook it together. Teresa, you're watching. On the geo board, when you connect those, do you have to put a single rubber band for each line segment?
You don't have to, but since you're already at the tilted squares section, I will say that the tilted square has many more advantages than the geoboard one.
I mean, it's easier. I mean, it's faster.
Exactly, yeah. So the one you have right now is indeed a square, but what's the area of that one that you have? And how could you figure that out?
4. So that's 4. It's 8.
How'd you do that so quickly?
Because I see these things. I looked right here and said, okay, here's my center. And I went over a base of 2, a height of 2. So I put these together. So these 2 bottom triangles would be 4 and the top would be 4 to get me 8. And I know if we start thinking, and I'm going to go ahead and take a screenshot and throw it in, but I know if we start thinking about this, I think we're going to find patterns where we can do this constantly somewhere. So 8's it's sort of like the 2. Ooh. 2, 8, maybe 2. Also, I know if I just took, I don't want to shrink it. I'm going to though. I know right here we've got this length is the square root of 2. And I just know from past experience that when we have 1 square root of 2, and if we pull it up here, 2 square roots of 2 is now 8. And then if we go out, let me see, 3, whoop. Okay, let's move you. Let's come over here and tilt it a different way.
And
There's
so
gotta be-
these are amazing generalizations. I want to make sure that Tamika and Linda, I put in the chat box the link. If you also tinker and play and you make these big discoveries, you find something new, take a screenshot and pop it on the slide. And if you need support with screenshots, just let me or Lisa know. We'll help you out with that.
Okay, thank you.
I think Tamika, you're much better at this than I am. But I'm just looking here. So now I've got I'm taking my mouse. I'm going up 1, 2, 3. Over 3. So if I did 3 times 3 is 9, and then half of that's 4.5. But this length, if I went outside here,
So first floor 1 by 1. So it's 1 inch, right? We're working in inches. 1 inch. Oops.
Yes, because she herself said 1 inch square tiles.
1 inch by 1 inch.
Look at you all finding all these really nice square setups.
Oh, okay. Okay, what's the notation, you guys, for square inches? I use square centimeters all the time. So
so you would just put inches and then you would do the exponent 2.
Okay. All right. Now, how do you say it? Because there's controversy where we are. I say square inches, not inches squared, because I think that has a different meaning. So I'm just curious if you guys get into that discussion.
Square inches is what I have used. If that's incorrect, I'm happy to be stand corrected, or however you say that.
No, I think that's the way it should be. Because if you say inches squared, like if you say 2 inches squared, to me that means 2 times 2 is 4, not the final area. So that's just the conversation I'm curious about.
Oh, no. I've only ever said square inches.
Okay.
Yeah, because square inches squared, you're right. It would, yeah. Okay, so then for the second one, let's do,
I'm trying to make this smaller. Just hang on. I'm trying to make this smaller, then you can just copy it.
Okay, perfect.
And then adjust. And I did the text white to match the white elastics.
Oh, very smart. I like that. All right, so then I'll do yellow for this one.
Yep. And I can even just move this down here.
So what floor is that you're working on right now?
We're doing all
I'm-
4 at the same time.
Yeah, but I'm sharing my screen, so I'm working on.
Oh, yes, you're right.
Oh, okay. So let me clarify some of the directions for this, because
Okay.
what I think I'm seeing is that you're making squares with a length of 1, 2, 3, and 4 on your slide. But if you look at the area, your white elastics, what's the area of that?
1 unit square.
One.
or
That
one?
would be for the first floor. What's the area of your yellow elastics?
It would be 4.
That would be the 4th floor.
Oh.
So you've got 4 of the floors done here. They're just not first, second, third, fourth. They're first, fourth, something and something.
So it's not the side lengths that match the floor number, it's the area that matches the floor
Area.
number.
So you've got 4 done, but I might recommend that you go to the second link, the enrich math, for the other ones, because they're not beautiful. I think we used another word in math, perfect squares. You're going to need to kind of tilt some of them on their points.
Mm.
Okay. I see. Second one.
Okay, so the area is 2 and the area is 3.
So
That's
I
what's
think for
happening.
the area that is 2, that maybe for we could still use this.
So the area of 2 is going to be the 1 root.
1 by 2. Hold on, let me get to that. 1.
Okay, so this is wrong. I'm just going to move this something here if we end up using this.
Ah, so what you have there indeed has an area of 2, but the Polygon
not a
Construction Company
square.
wants what kind of shape?
Right, it has to be a square.
Ah, has to be a square.
This is where the side length is where root 2 by root 2.
Ah, so how can you show that on the pegboard or on the tilted squares?
Yeah, it's about 1.4 is what I think. So now we have to. And then the third floor will be root 3 times root 3.
So it sounds like you've got some good generalizations, but then the big question is why? So see if you can make it snap to the pegboard, paste it on, and I also recommend that you don't go in order like 1, 2, 3, 4, 5, because some rooms some floors are harder than others. You just tinker with it. When you find one, you celebrate and pop it on that floor.
Okay.
So you know what I'm thinking, Raha and Laura? Instead
Go
of
ahead.
deleting this, let's just put an X through the ones where we made a mistake.
Okay. That's
And then
fine.
we're going to duplicate this slide. Just a second, duplicate. There. And if we duplicate on this,
That was there we go. This will be yellow, be a little nicer.
Okay. So that side there is 1.
Oh, I like the arrow. Yeah, I'm going to put in a different picture, but keep going with the arrows. Let me just get one
And
that-
the other
that
one
has-
there was the square root of 2 because it was the diagonal. Yeah, I'm just stealing Teresa's arrow thing.
Yeah, it's great.
Yeah, since she's in here, we might as well give her credit for it.
Hey folks, I'm so curious about the color coding that you did for the 5th floor. And I know you're up on 3, so I don't want to derail you too far, but why did you use those 4 different colors? What does it show us?
I think that was me. I think I was just trying to make show 4 different 1 by 2 right triangles. I first had that one for 3, and some nice members in the group very nicely pointed out my calculation mistake. But each triangle on the 5 is a 1 by 2, so the hypotenuse of that would be square root of 5. So I was just trying with different colors to show the 4 different triangles.
I can really see those triangles very clearly. And I did the same thing. I saw it as 3, and I was like, oh, wait, those together. Very cool. We'll keep on working. Y'all are doing a great job. I see you found several of them, 16, 5, 9. Yeah, just see how many out there you can do. We'll come back together in about 4 minutes. It's not expected that you're done. It's expected that you explore.
Great. Thanks, Stacy, for those labels.
Was explode that out.
Teresa, I went and perused another group, I guess the group 1.
Mm-hmm.
What are they using to make those images?
What slide? Are you looking at slide 21?
Mm-hmm.
Okay, she gave us, let's see if I can slide over on theirs. This very first geo
board is the black background. It mimics using those little rubber bands, but it doesn't have as easy of a way to, just rotate that square till you find what you're looking for. You kind of have to know what you're looking for first and model it. So those are some of the differences between those tools.
Okay.
And like here, she's showing up here. She's got that, what I drew on my paper right here. It's hard to see.
Mm-hmm.
That's what they're showing us on the purple with the little yellow. That's how they're showing that picture. And then they would drop down, and if once they get to 8, the 8th floor, it's going to look like this. So all the side lengths have doubled. And then when we triple that 3rd side length, we're going to get 3 times the square root of 2. And that's what I was trying to draw on the 18th floor. And that's where I'm having trouble drawing. But by doing what they did with geo boards, you can see the little, like right here.
Mm-hmm.
So this is 1 square. So this is 1 square unit. So this is a half where my mouse is. So if we drop straight down here, there's another half. So a half and a half. That would make us 1 square unit, and over here a 2nd square unit. Does that make sense?
Mm-hmm.
And then over here, they tilted, and let's think in terms of slope of a line and be lazy and just go rise over run. So they went up 2 over 1.
Yeah, so the 2nd floor will be closer to 1, and the 3rd floor will be closer to 2. Oh, that looks so hard.
I mean, there's a reason that maybe the online manipulative doesn't let you do it, but
yeah. Oh, there's Teresa. Teresa, we tried to use that other website, and we found it snaps right back to the whole distances. So
it does.
Is there a hint on how not to snap it?
It does. No, instead of trying to make it not snap.
Oh, we turn it on an angle.
Turn it on its angle.
Then it works.
And then try to see if you can find the shape.
That's how it worked. Okay, we were trying and it kept snapping, but I just twisted it and it stayed.
Yeah, so the
hold on, let me
mathematics
try.
wants it to snap. That's kind of keeping the math in bounds. Yeah, keep tinkering with it.
Okay, I just drew
Kathy,
one.
did you get it? So were you able to
Can
get
we
it?
see it? I want to. Kathy, are you able to share your screen?
Oh, she
Because I can't get it
just
to be
did on
less
slide
than
31.
1 whole.
Here, have a look on 31. So what I
Okay.
did was I grabbed the red dot and
Okay.
just slid it so that put it like on a diagonal, and then you can size it however you like.
Okay. Hold on. Let's see.
And if you can't see it, then I'll share my screen.
No, I saw your screenshot. I'm just not able to get it. Oh, there it is.
Yeah, so let's say just leave the blue grab the red, make it larger, and then swing it. And stop at a point, and you'll see that it stays.
But I'm still getting perfect squares, I guess.
No, because they're on a diagonal, so they won't. They'll be off. Because a perfect square will be whole numbers only. 2 times 2 is 4, 3 times 3 is 9. So these are the in-between numbers.
So that's the second one, right? That's that's the area of 2.
I think so, if I did it properly. And then if I do, okay, so I was trying to do like 1.4, and then I was going to go like this. Okay, I'm
Right,
going to
'cause we
capture
want-
another one and see if this makes any sense.
Because you want it to be
Okay. I'm just setting up my conversation. We'll start with group 1, who discuss perfect squares and kind of in-betweenish of perfect squares. Group 2, I'm going to have go last because they're talking about this idea of root 2, and that's the higher level thinking that we're not quite ready to share yet. Group 1 decomposes triangles on slide 22. Then I'd like to go to group 2 for root 2 explanation, and then back up to group 1 for the third floor. If you're watching this, these are the 4 that I'm gonna, whoa. Yeah, my screen's not showing. These are the 4 I'm gonna try and do in the conversation. I'm gonna close the breakout rooms now, and we are going to chat about this. Hello, everyone. Welcome back to the main room. What I think makes this task so fun and so juicy is after 20 minutes, you have explored to the point where we are ready for our whole class discussion, yet it's going to leave you wondering. It's a great way of, giving a homework that people care about and giving more exploration time to prove. So let's go ahead and have our discussion. I am going to move us to slide 37, and I'm also going to share my screen. Alrighty, so on slide 37, I have how I usually structure a math talk. I've already anticipated, which you'll see in a minute, many different solutions and ways to visually prove very high-level thinking geometry concepts. I've monitored, you heard me go in and out of your rooms. I've selected in sequence. I've got my little list here of the ones that I want to go over in our session in order to make some strong connections. So even though your group did many, many things, what I've done is selected ones that will go in a nice order for our conversation. And I would love to start us off on slide 38. This group did some really amazing math thinking, and then they changed the way that they were thinking with this. But let's just go to the very beginning. why are these squares so easy to do, these first 4 that you have? Can someone from this group just tell us what you started to do here?
So I'll speak to this because the other ones are a little bit more complicated. So they'll be better. Laura and Kathy will be better at speaking for those. But we were under the misconception that we're using the side lengths as the floor number we're on. So like for the first one, if we're on the first floor, the side lengths are 1 and 1. So then the area would be 1 unit square. And then we were assuming for the second floor, it would be 2 and 2. So we're thinking of perfect squares for these. But then you came into our room and you shared that that was the misconception. We're trying to make the area 1 unit square or the area 2 unit square. So it changes our lengths.
Yes, and that's something that a lot of people start off with this problem, but it's an important thing to discuss because so often we mix up perimeter, area, side length, and more. So let's throw it all in the same problem. But Raha, you do have an X on the red one. Do you remember what floor that one went to? I think some of us had this one.
I think we said that was the 3rd floor, but that's actually the 9th floor.
Right. So as a side length of 3 and an area of 9, and then our last one here
would be 16th floor, and the side lengths are 4 and 4.
Yeah. So these are typically the first ones that students start with. We like these ones because they're quote unquote easy. In other words, they're perfect squares. But then we had to get into some other stuff. And there was a quote that somebody said in group 3 on slide 39. They started to do their work for it. And they said, oh, floor 2 should be closer to floor 1 and floor 3 should be closer to floor 4. So this idea that we have 2 perfect squares, but how do we find something in between? Almost like a number line. Group 3, did someone want to continue that part about your thinking and how you had to figure out what went between the white and the yellow?
I can try. I guess what I was thinking, and when we realized we made this mistake, is that the side lengths, so on the first floor, the side length is the square root of 1. The side length of the second floor is square root of 2. Side length for floor 3 is square root of 3. And we just kept going. And so, because square root of 1 times square root of 1 is 1, and that gives you the area of 1. So I kind of confirmed that generalization. And then I knew that the square root of 4 is 2, the square root of 1 is 1. So the numbers had to happen in between, had to appear in between if we were imagining on a number line. And then it was just a discussion of which one is it closer to? And then we made some estimates as we got going.
I love that this idea that your side length needs to be like somewhere between here because the area needs to be somewhere between there. And that's something you mentioned number line, but I'm almost thinking double number line, like side lengths on one, area on the other, and we'll find that there is a relationship between them. All right, so, students could be working on that. Another great area, and this one becomes very accessible to our younger students too, is when we start to look at shapes by decomposing the shapes. Group 1 on slide 40 started to do that in a lot of different ways. Could someone from group 1 kind of explain us your strategy and just how you were able to find the area of these?
Sure, I can talk about the 5th floor one. We first had that one as a 3rd floor, and then we realized that was wrong. But each of those triangles are a 1 by 2 right triangle. That one in red that's being pointed out. Thank you, Teresa. So that had the hypotenuse of that is the square root of 5, 1 squared plus 2 squared, and then so we took 4 of those triangles to put them together to make a square on the inside that had side lengths the square root of 5. At first we thought it was 3 because we were just doing the 1 plus 2 and forgot to square them, but we problem solved together and then moved out to the 5 one. And then the same thing on the 8th floor with a 2 by 2 right triangle. but we didn't quite get there for 6 yet.
Yeah, yours is very visually pleasing. Like I can really understand it. Now, there's two ways that students will typically decompose these shapes. They will either see the outside most bit and remove triangles, or they'll see the innermost bit and try to make rectangles that they can move out. Which way did you guys happen to go?
I think I on the fifth one at least, I was just trying to create a length that had I was trying to make a line that had a length the square root of 5. So I actually wasn't thinking about it as decomposition or composition of area. And then I was using those triangles to build those lengths.
I see. So you used your knowledge of roots in order to find that piece there. Cool.
Yeah.
So these triangles can be really useful in helping us find pieces. We've heard now a couple folks bring up this idea of square root, and that's definitely something in secondary mathematics that students are doing a lot. I think it was Lisa on slide 41. I took a little screenshot of your work here. Can you give us an explanation of like, what is this root thing and how might I be able to find this?
Okay, I will try to start, and thank you for getting that picture. And I've extended my picture now, so I have a side length of 3 times the square root of 2. But I knew that the second floor had to be tilted, and just from what we've done in math class, I knew the length of one side of this tilted square was the square root of 2, because if I outlined here, this length is 1, the other length is, well, let me go to the inside of the square. 1 by 1 is a length of 1. The hypotenuse then would be the square root of 2. So this over to the right-hand side, that shows a length of 1 times the square root of 1, and then each smaller piece inside is 1. So if we work this, each of the smaller triangles is a half square unit. So 4 halves give us 2 whole square units. And the second picture to the right would go to the 8th floor, which I think I finally got that moved to the 8th floor. And it's the same thing, but we've used scale factors here and doubled the length of all the sides. So now we have, in the smaller triangle, the base is 2, the height is 2, the hypotenuse is 2 times the square root of 2, which if we go back and do our math, we come up with this little piece has an area of 2, that top right triangle, and then the 4 times 2 gives us 8. And this extends like I've got on my paper, I drew a picture of the 18th floor that has 3 times the square root of 2. And I'm thinking, okay, the next one in that pattern is going to be the 32nd floor. Will have a side length of 4 times the square root of 2. And that just continues on and on and on.
So it sounds like this kind of square root of 2, a lot of folks were jumping to it. But Lisa, when you did it start off with this idea of 1 squared plus 1 squared equals 2 squared, or did you not start with that initial thinking?
Back when I first did this yes. Today I already knew that, so I didn't have to, but yes.
Awesome. So
and then my class played with geoboards. We have physical geoboards, and we actually use the rubber bands so they could hopefully see that. But this is really throwing me next year. Let's use this and also explore some similar squares like this. I mean, I know all squares are similar, but where they look, they're resting the same on the geoboards or whatever.
Yeah. It was great that you were able to bring back the Pythagorean theorem without even really mentioning it. Like that was your prior knowledge into this. But for those of you who maybe don't teach Pythagorean theorem, it's been a little while. On slide 42, I tried to capture some of Lisa's thinking. And, if this were in a class, we can always do small groups where some students who've shown mastery of this might work on a slightly different task than those that just need a little bit more practice with the idea of how this connects. Awesome. And then speaking of this whole root stuff, this whole square root stuff, we have one more to look at. Slide 42, group 1. Now, you all had a lot of interesting shapes going on here on the 3rd floor. I'd love for you to hear about how this connects to your 5th floor.
Anyone else want to talk about my mistake besides me? I'm happy to, but anyone else want to chime in from group 1?
Yeah, well,
Go
I have to
ahead,
admit, he had us going. I mean, we all went with it. And like I said, I blame the lack of coffee. That's where I'm going with it. But yeah, I loved his, because I marked them as 1, 2, and I didn't catch it until he mentioned, oh, it's not a right triangle. And I'm like going, damn it, but it's so pretty. But so then we got so excited that it was square root of 3 that we used it for another floor, so once we made that mistake, it just kind of cascades. So, oh, well.
Oh, it seems like a mistake was more of an observation that got you to a generalization.
Yeah, so it was fun. It's good to be wrong.
Very cool. And I love seeing the Pythagorean theorem being used for showing that obtuse angles in these triangles. Like, so often it's just in right triangle world, and we never really think about acute or obtuse. All right, folks, I hope that you found this task to be accessible, whether you are teaching, elementary school and we are just talking about how to slice a square in half or in half on a diagonal, and you can find area visually, all the way up through high school as well. I do also have some student work samples that I'll put on here that I think you might be interested in. People often ask me, how do you anticipate? Like, what are you doing when you anticipate? And there were, 4 really specific things that I was looking for in your work in order to bring up to the whole group. And I'll share those here on the slide below, starting on slide 43. These were the strategies that I was anticipating. The idea of those perfect squares, the idea of decomposing into smaller pieces. On slide 45, we're starting to see that we can decompose into lots of different pieces. They don't just have to be cut exactly in half. And 46, they did the same thing, but they found that there were 2 equal halfy bits and they were on 4 sides. So they were able to make more of a generalization. On slide 47, we do bring up the obtuse triangles and ways to see them, again, visually. This is very elementary based here. And that brings us all the way to slide 50, where we can enclose a square with another square and then remove out those triangles. So when I say I anticipate, these are actual strategies that I was looking for in those, knowing that since I put this up as high school, we would probably have a lot of root talk. So folks, there you go. There's how you take a problem. You stretch it from elementary all the way through high school. The questions I anticipated are on slide 96. And I've also got lots of upcoming sessions coming up. Those are published on slide 98, including mark your calendar for our guest speaker who's here with us today. David, do you have any, do you want to mention anything about September 25th or just mark your calendar?
Sorry. Mark your calendar. I'm excited for the opportunity. Thanks for having me, Teresa, to talk about Mathagon and Polypad. There isn't a geoboard per se on Polypad. I just saw it in the chat, but there is a custom polygon and a grid background, so you can have the same, the same impact as a geoboard with putting a grid background and the custom polygon. Maybe I'll talk about it on the 25th.
Cool. Can't wait. All right, folks, have a great Saturday. Happy MATHurdays. Happy weekend. If you do have questions about tech or pedagogy, I'm going to stay on for those. But otherwise, have a great Saturday, and thanks for joining us.
Thanks very much. That was a great task. I've never done that before. Have a great day, everyone.
Thanks, everyone.
If David's still listening, I wanted to let him know I did watch his Polypad webinar on Wednesday, I think it was. It's really good, and he goes so fast. I'm like, okay, I need to go back and rewatch it in half speed or something. So, Teresa, I'm assuming you're going to pretty much take off during August.
I do have another August date in here that I just put up.
One